the laparoscopic surgical instruments, specifically in India, in rural Indian hospitals, were cleaned with nothing but a needle or a brush and some detergent soap. And a lot of the gunk and the bioburden and the debris used to go all the way till autoclaving. So basically, what had happened was this bioburden would just cook onto the surgical instruments. So it didn't really make sense to go into the whole deal of sterilization or looking into the other aspects of cleaning these surgical instruments if the basic level of cleaning with a brush is not done properly.
Rising above the buzz of ultrasonic cleaners and the clanking of stainless steel are the ideas and voices that are changing an industry. You're listening to the Beyond Clean podcast, the central nexus for the people, processes, and products that are improving our sterile processing world. Each week, we speak with frontline technicians, CEOs, engineers, and entrepreneurs with a common goal to help you fight dirty. Every instrument, every time. Whether you are tuning in for education or inspiration, we're glad you did. Now, turn on those washers and turn up the volume. It's time to go Beyond Clean.
This week on Beyond Clean, we speak with Girish Malagi. Girish is an architect turned industrial design engineer. Born and brought up in Mumbai, India, his curiosity in hands-on work led him to an interest in industrial design. He then went on to pursue a master's degree at the Delft University of Technology, Faculty of Industrial Design Engineering in 2018. There, he took up projects pertaining to designing for context-specific resource constraints in low and middle-income countries, or LMIC. Driven by his interest in design for healthcare in LMICs, he took up safe laparoscopy in rural India through sterile processing of laparoscopic instruments as a graduation project. The focus of the project was the cleaning stage, as he found that there can never be sterilization without cleaning. After 6 months of research, testing, and design, he designed a concept for a frugal mechanical washer for rural India, which cleans the instruments through mechanical brushing action instead of impingement. He is currently based in Delft, the Netherlands. And Hank, this is going to be really interesting because we're talking about areas of the world that are starved for resources, and water being one of those that is at a premium. And as a result, traditional cleaning methods with, I'd say, a pretty good use of water, or that impingement process, as is described in Girish's bio that I just read, instead got to substitute with something. You have to be innovative. And in his case, mechanical brushing fits the bill. I can't wait to hear this story and the impact that this innovation is having on improving the delivery of care in these LMIC, or low to middle income countries.
This interview, Justin, is another great example of the power of LinkedIn. We say it time and time again. It's the story of our podcast. It's how you and I got connected. It's a story of a lot of interviews through the last 3.5 years. And this is another one. I got a LinkedIn message. He attached the PDF of his research project and said, "Hey, I've been working on this. Is this something that you would just like to check out?" And I read it and then followed back up and said, "This is awesome. This is a story that needs to be told. Can you join us on the podcast?" And here we are today. So if you're out there listening world and you've got great ideas or insights or a topic that you want to share with us, contact us through LinkedIn. Hit me up through private message, whatever you want to do. That is your number one way to get on the show and share your passion with the world.
Yeah, I'm looking forward to this excellent story today. We're going to be right back after a short break with Girish Malagi.
You're listening to Beyond Clean, the global voice of sterile processing.
Joining us now is Girish Malagi, product development and design engineer at Loop. And Girish, the thing that I'm most interested to hear you talk about today is this term. It's in quotes as I looked at your paper, envisioned reprocessing journey. And it just indicates that there's a whole vision for improving the way things are done. And we're going to be talking about the country of India. So this is the global voice of sterile processing, and we are very excited to have you on as yet another global voice here on Beyond Clean.
All right. Thank you so much. Thank you so much for having me.
Why don't you give us a little bit of your background? I read your bio when we started out to introduce you to the podcast in our intro, but I'd like to hear a little bit more of your background and experiences that led you to the topic that we're going to be talking about today.
Yeah, I was born and brought up in Mumbai, India, and I studied architecture. That is completely different from what I just did. And worked in fab labs in Mumbai, where I got into the whole thing of product design, product development. From there, I said, hey, you know what, let's do a master's program at the TU Delft. That's in the Netherlands, the Faculty of Industrial Design Engineering. That's where I worked on a few projects with low-income resources, low-income settings. One of the big problems is just surgical safety and just basic healthcare in low resource contexts. And taking up a project like this, it was a pretty seamless approach where I took an elective called Design for Emerging Markets, where there was a PhD researcher who is still working on laparoscopic surgical instruments and how to clean these surgical instruments in rural contexts. So I just took it up as a graduation project for my master's thesis, and here we are.
And one of the interesting backdrops to this conversation is, I know we're going to be talking about low to middle income countries and context, but this challenge, this laparoscopic cleaning challenge, is a challenge in every single context. So what that means is, as we go down the chain of resources, if it's challenging in a high income setting, then that those challenges are multiplied and even more severe with less access to various technologies, equipment, chemicals, whatever it is. And so I just want to lay that out for the listeners. I think everybody who's listening to this podcast in sterile processing is already at that place to where, okay, we're familiar with the challenges, no matter what context you happen to be working in. But in particular to this conversation in your research, to really put that in the setting that you spent most of your time in confronting and outlining. And again, that's the low to middle income context. Why did you focus on that topic in that context in particular?
When I did a little bit of field research in the Dutch hospitals, I see that a lot of systems and processes are already in place. There is a certain guarantee to cleanliness and sterility of surgical instruments. But rural Indian hospitals and rural hospitals in general, be it India, be it Africa, be it any of the LMIC nations, you have so many resource constraints. And that just brings up the challenge of how can you completely challenge these resource constraints and still get significant amount of cleanliness in surgical instruments. So it is a challenge that I'd really like to take up. And being from India, I've also seen what it is like to do a surgery in rural Indian hospitals.
You mentioned an acronym, and I just want to define this for the listeners too, because this is all throughout your research, but you said LMIC, so I'm assuming that's low middle income countries, right? And then as you said, we're going to talk a lot about the context and the application to India, but to your other point, these countries are spread across the globe on almost every continent. And even in settings like the US, for instance, where you would assume everything is a high income type setting, there are still access issues to the proper cleaning equipment or to properly maintain cleaning equipment. And I don't want to get us off topic here, but I want to continue to tie in these topics to, this is not an isolated conversation that you're having that's just applicable for one country on the globe and one challenge. It really is interconnected across the board because, as we'll talk about here in a moment, the concepts for cleaning and engineering cleaning, that's just basic science. And that's science that's transferable no matter where you live and no matter what hospital you work at. You need that approach and that availability to that science and to that technology to get things clean, especially when those things happen to be complex laparoscopic devices. And so we understand a little bit about the background here, but I'm curious, especially because we don't talk to a lot of researchers like yourself who have done field research and gathered information to complete your thesis. So can you talk about how you engaged in that research, how you gathered information, and if you got any surprises along the way?
So I think the biggest surprise was COVID-19 that kind of just spilt the entire planning out. So I was supposed to go to India in March for my field research. So basically, this project is a part of a larger ongoing PhD research at the Delft University of Technology. My 1 month research trip to India was completely cancelled a night before I took off in March 2020 because of COVID. All the field research was based on the data that was collected by my problem owner. His name is Daniel, who's also doing this PhD. And he was in India for a month before I was supposed to meet him. And also, I was born and brought up in India. And I've happened to travel to a lot of rural hospitals in the past during my architecture studies, where I would do case studies of rural hospitals to design new architectural spaces for these rural hospitals and primary healthcare centers. So Daniel's findings plus my own experiences, they really helped me build a very coherent foundation. I contacted a few friends who are also surgeons, and some interviews with them and a few rural Indian nurses just put things into perspective. It was pretty surprising that the conditions in the sterile processing side of these hospitals are not as bad as I expected. So these hospitals weren't all that destitute as what we would picture it to be, but some improvements were definitely required.
Well, it's interesting that you say that, Girish, because at the very outset, you said, I know what it's like in these LMIC or low and middle income countries because I've seen it. And I was getting ready to ask you, can you describe to us what that is like? And now you're sounding like also it's not as surprisingly concerning, still concerning, but not as surprisingly concerning as you thought it would be. Can you paint that picture for us? Where do you think the opportunities for improvement are, or where are the shortcomings that are so concerning?
Mm-hmm. So basically, first, the main situation in rural hospitals is that there aren't any set protocols that sterile processing technicians follow, because there really aren't any sterile processing technicians. And it's the nurse. The nurse does all the work, which means cleaning the surgical instruments, prepping the operation theater, prepping the patient. So the nurses are extremely overworked. And so there aren't really any specific guidelines that are followed in rural Indian hospitals. So, and in that context, there isn't any specific protocol in the space or in the space where the surgical instruments are cleaned. So in many of the hospitals, we noticed that the surgical instruments are cleaned right outside the operation theater. So you have a lot of issues when it comes to cross contamination.
And Girish, when you say outside the operating room theater, do you mean in the hallway, or do you mean in a room across the hallway?
It could be in the hallway. It could be as soon as the doors of the operation theater open, there's a long sink with a few faucets right on the wall that shares, the wall that's shared between the operation theater and the space outside. These are not purpose-built sterile processing departments.
What about washers? Are they entirely, I really want to get people understanding, if they were to look down the hallway, what they might see. Are they using any kind of automated washers, or is it all hand washing?
It is mainly hand washing. It's like, I think I would say at least 98% hand washing. So out of the 4 hospitals Daniel visited, there was just one rural hospital that had an automated washer disinfector, but the washer disinfector was not used because it was too expensive to use this machine. The water and the electricity flow in these areas are very erratic. So there's so many different parameters that come into play. And also that the amount of surgical instruments per batch were too less to be put inside an automated washer disinfector to run it economically.
Wow. Yeah. Nobody ever thinks about necessarily a natural resource that we come by so easily in the United States. So I'm assuming at this point that ultrasonic cleaners are completely out of the question.
Ultrasonic cleaners were not seen anywhere, even though they are such a no-brainer technology. They're just not used. And also, the water in rural parts of the world, or rural parts of India at least, it varies a lot from place to place. You can't have a consistent quality of water. So the whole reverse osmosis deionization and stuff just does not work in rural areas because they just don't have the technology for it. So using automated washer disinfectors and using ultrasonic cleaners would actually could in a sense make things worse because there is a lot of salts and minerals in the water.
And then when you talk about laparoscopic instruments, which I know we're going to be targeting here, lap instruments have long cannulas and very difficult to visualize areas. And in most cases, many facilities are using some sort of an attachment for their ultrasonic cleaner to be able to get into those difficult areas to clean with laparoscopic instruments as well. So as you even look at the benefits of using laparoscopic instrumentation, one of those meaning you're not doing an open procedure and there's less risk for infection. There's a little bit of weighing competing potential hazards or risks around infection, both in the taking care of the patient and preventing infection, but also the ability to clean the instruments. I can see where there was so much of a open playing field for you to go in and take a look at. There's got to be at least several different ways where we can really assist and make a significant improvement.
Yeah, precisely. So this was something that was just not addressed before, because a lot of the innovation in the realm of surgery is mainly in designing and developing new surgical instruments. But what I've noticed in many projects that I've gone through as well, is there really isn't any focus on the back end. It's like you create a beautiful device, but how do you maintain the device?
Yeah, no, you are singing from our song sheet there, because we've talked about that on a number of episodes. That is it's a global problem again, to blow this back out, but it's a problem, to your point, that is only intensified as the access to resources and equipment becomes lower in some of these areas. And so I'm wondering, I feel like we have laid out the challenge, pretty clearly here, but start walking us through the solution, right? So in confronting the research and looking at the problem, I'm assuming you and your team, first step is the brainstorm. What do we do? Like, how do we approach and create a solution? So can you walk us through from that brainstorming phase all the way through to validating what your solution would become?
So this was literally the most exciting phase of the project, that is, from brainstorm to validation. So I had already established that the scope of the project was the initial cleaning, because you see, there can never be sterilization without cleaning. It just does not happen. And that's why I chose to tackle the problem at a very grassroots level. So the thing was, the laparoscopic surgical instruments, specifically in India, in rural Indian hospitals, were cleaned with nothing but a needle or like a brush and some detergent soap. And a lot of the gunk and the bioburden and the debris used to go all the way till autoclaving. So basically, what would happen was this bioburden would just cook onto the surgical instruments. It didn't really make sense to go into the whole deal of sterilization or looking into the other aspects of cleaning these surgical instruments if the basic level of just cleaning with a brush is not done properly. The hospitals did not really have any mechanical washers because they were too expensive. They demanded a lot of water. And also water, as I already mentioned, water and electricity in these regions are really unpredictable. So I had to design a frugal alternative to the existing washer disinfector, which would demand a considerably less amount of resources. And that's how the frugal mechanical washer came into being, and which kind of rids laparoscopic graspers and trocars of a lot of dirt, and with a simpler technique that's just mechanical brushing.
Now, because we're on an audio podcast, obviously folks can't quite visualize what this solution would look like. So could you describe, if you were to look at it, and I know we're going to attach a PDF to this episode so folks can actually read all of your research and then see some of the diagrams and photos in there. But for this show, can you just kind of talk through, if we were to walk in and see one of these units, what will we see?
Basically, the little washer that I've designed is a very basic keep on top of a table kind of a washer that cleans a very basic amount of surgical instruments. They're just graspers, the graspers, inserts, and the trocars. The main idea is that we use brushing, mechanical brushing, as compared to impingement that happens in existing automated washer disinfectors. The shear stress that is applied onto the surface of these surgical instruments through water pressure is now being done with just mechanical brushes. So what happens is, as soon as the laparoscopic instruments come out of an operation theater, the nurse would just quickly rinse these surgical instruments under running water, just remove the blood, remove some loose bioburden, and then directly dismantle them and keep them inside a cassette system where the graspers are opened and exposed. This cassette is then just inserted into a little chamber with 3 brushes, which would brush the grasper tips. That's pretty much the most difficult part of cleaning a laparoscopic grasper. Through a lot of testing and research, I've noticed that 3 brushes attached in a triangular fashion really did help clean the hinges and also the teeth. And then for the trocars, the surgical trocars would be brushed with a vertical set of brushes that are attached to something that's very similar to the crankshaft of an engine. And all of these are run by a single motor. So basically, the amount of moving parts needs to be as less as possible, and also that these brushes need to be replaceable. And that's pretty much the reason why I've designed this product. So there's a lot of design for repairability and design for easy replacement.
I love this conversation. I love your approach to the challenge because it just highlights so much of the basic concepts of clean and the basic science of friction, right? As you mentioned with the brushes. And it's an interesting balance, right, that you have taken to try to overcome those challenges of access to water, for instance, or access to the types of high quality water that some of us just assume. And to do that in this creative and innovative way that can be scalable and repairable, to your point, right? Because the last thing you want to do is spend all the time and effort to create this great solution, implement it in the field, and then something break and it go in a corner and not be used, right? Just like the other washer disinfector that you saw in the field. So it's such a great insight, I think, to what innovation looks like and how to look at these challenges in the industry and then try to creatively solve them as your team did. So you talked about in the research, if there was any surprises, but I'd also like to ask you, in completing it and putting this whole vision together and validating the solution, what were some key lessons that you learned through the process that you may not have known coming in, or just experiencing that growth and insight as you took that challenge to solution? Like, what are some things that you're going to walk away with now?
So some of the biggest lessons I've learned from this project are how extremely important it is that a field research needs to be conducted, especially for low resource settings and contexts that are different from where we live. And that's mainly because, and I think that could have definitely changed the outcomes if I had actually gone to the field and done a stronger field research. Because I had started off with an assumption that the more poor, the more rural, and the more remote these hospitals are, sterile processing regions and the surgical conditions in general are going to be really, really bad. But they weren't all that bad. So it's really important that every designer or every engineer who is tackling problems in such contexts or in any context definitely should go in the field and be in the field and actually break everything down into first principles and just break everything down into the littlest, smallest of the smallest problem, and then pinpoint exactly what needs to be tackled. And then I also think that it's really important that we do pump in funds and resources into the developing world a lot more than we have been so far, and also into developing surgical infrastructure for the low and middle income contexts, because in the future these regions are the new frontier. This is where most of the population is going to come from, and also this is where most of the talent and is going to come from.
Well, You basically teed up my last question for me. You almost could have asked it of yourself. As you describe that, clearly there's going to be opportunity for more innovation and improvement. Where do you think those other opportunities exist for low and middle income surgical safety?
Other than designing products and designing new machines in the market, I mean, that's something that I really enjoy doing because I'm a product designer. I see a lot of potential in creating stronger awareness of the actions of the people behind sterile processing, that is the surgical staff. So I think that the awareness and the education would itself play a very strong role in cleaner and safer surgical instruments and surgical outcomes. Because the nurses in rural India are not all that educated. They are just doing this as a job or a means to get by and provide for their families. A stronger level of education for these people would go a long way because they need to know what they're doing and they need to know what the repercussions of their actions are. So when it comes to education, it means they need to be trained on how to also test and visually inspect these surgical instruments by providing them with the knowledge and also the equipment like having microscopes and
Or insulation testers, still within that realm of laparoscopic surgery.
yes, there were no insulation testers at all.
But that doesn't require water. In most cases, it's low electrical supply, right? 9-volt battery. And I would even think that cost effectively, that would be lower. And when you understand just the total risk around electrosurgical burns during a patient that are not visualized in the surgical field and may not be even known at the time of the incident and what that means for post-operative complications, that's a huge one. And that seems like a winner for me, an easy one.
Yeah. So basically, this one thing that we noticed was rural Indian hospitals or rural hospitals in general tend to use disposable surgical instruments like multiple times. Like I think way past its recommended life. There really isn't any law regarding this that says that hey, you need to dispose it after one use or you need to dispose the surgical instruments after a certain set of uses. And because these instruments are made of plastic, and there isn't any low temperature disinfection like the ethylene oxide disinfection going on in rural hospitals. So everything is just done by hand, brushed by hand, and just immersed inside butyraldehyde, that's like Sidex solution. So even electrosurgical instruments are cleaned the same way as every surgical instrument, as every laparoscopic instrument. So when it comes to insulation testing, I mean, at least we didn't see it.
Well, Girish, I have a feeling we're going to continue this conversation over the next several years of the Beyond Clean podcast because there is such a great deal of opportunity. And I think there's also a lot of willing support from the industry. And maybe you'll hear it from others who have ideas of cost-effective, low resource demand opportunities to make a significant impact on quality. And who knows, maybe there'll even be fundraising efforts for something like that. I got to tell you, I think you really opened some eyes, and I appreciate you allowing me to walk us through what it would look like in the hallway and what equipment is there. You did a really nice job of giving us a look into a world that, quite frankly, I've never seen firsthand. And it makes it a lot more real for me to understand it that way. So appreciate you coming on and sharing your success story, but especially what you've already done to improve the delivery of care in these areas by coming up with something truly innovative and a solution that is going to work in a different environment.
Thank you so much.
That was Girish Malagi, product development and design engineer at Loop. And honestly, Hank, this is a whole different world for me. I am sure that there are plenty of our colleagues out there who may have made some mission trips and had a look at low to middle income countries and the state of healthcare. But I don't know, even amongst all of the conversations that we've had in the past, that we've ever really gotten such a clear picture about what is available, what's being worked with. I know we've had loose conversations around natural resources and limitations. But boy, this really hit home. And so much of our show is built around innovation and disruption. And I just think that the way that those two worlds collide on this episode with Girish was really a testament to his ingenuity and a really great success story. And honestly, I think it would be surprising if we didn't hear from our listening audience with other ideas or concepts that obviously might not apply in a country like the United States, but might be good ideas that Girish could take into account as he continues to do the great work that he's doing.
Yeah, Justin, if there are folks that like this conversation, we've done interviews with Christina Fast, who does a lot of work outside of the U.S. and Canada around sterile processing education. And in fact, her group is called SPECT, the Sterile Processing Education Charitable Trust. And it lines up perfectly with the final words of this interview, which is the solution is education. And that is right in line with our mission. And thankfully, because the podcast is global, because we're downloaded now in over 140 countries, many of the folks tuning in are the folks in these low to middle income countries. And as we have these kinds of conversations and share this insight, I hope the folks in the field get encouraged that they can develop these solutions and implement these ideas with the right network and with the right connections, like what we're building through Beyond Clean globally. So I'm very encouraged, and I hope folks in the listening audience are as well.
Yeah, it just always reminds me how important it is to have inspiring guests on these episodes with multiple different perspectives. And again, we've done a very nice job of that this season. And it's great, that story you told us about how you found Girish to do this interview. So once again, the power of the internet. That's going to do it for this week's show. As a reminder, you can help support Beyond Clean by subscribing on iTunes, Stitcher, Google Play, and Spotify, or by downloading our smartphone application for iPhone and Android. And we do have bonus content available there, and we do for this episode with Girish as well. We'd certainly appreciate a rating and review because your feedback's important to the show. And if you have any topics that you'd like us to cover on a future episode, just send an email to info@beyondclean.net. On behalf of Hank and myself, thank you for listening to this week's episode of Beyond Clean.